Question number 6.29. Radiation of atomic hydrogen falls normally on a diffraction grating with the width L equals to 6.6 millimeter. The 50th line of the Balmer series is observed spectrum is close to resolution of this diffraction angle theta. Okay, so find that angle. So basically there is diffraction grating. Okay, and gratings are separated by the width 6.6 nanometer, 6.6 millimeter in fact. Okay, and hydrogen beam is falling on it. The range of the series is Balmer series. Okay, and we already know for Balmer series 1 over lambda is equals to R, 1 over 2 square minus 1 over n square, where n is greater than or equals to 3. Right. So for that we see the resolution limit. Resolution limit we see for that if for any angle theta. Okay. So from here we can say that if angle is theta, then this L sin theta over lambda, whether lambda is wavelength during that emission, that must be equals to delta lambda over lambda, the resolution limit. Right. So let's start with this problem. That if we look at the Balmer series expression, then energy in case of Balmer series, which is E equals to H into omega n, it can be written as H into R into 1 over 2 square, that is 4, minus 1 over n square. Right. So we can write total energy 2 pi H C over lambda is H into R, that can be written as 13.6 electron volt. This Rayburn constant into H cap is equals to 13.6 electron volt. We can use this concept later. 4 minus eta square. Okay, here we need to check the resolution frequencies, that how they differ. Right. So resolution means the capacity to separate out between two closest wavelength. Okay. So this should be lambda over delta lambda in fact. Right. So we can calculate nth wavelength. Suppose this is lambda 1. So in similar pattern we can calculate next wavelength n plus 1, that is h into r 1 over 4 minus n plus 1 ka whole square. Okay, this 1 upon n plus 1 whole square. Right. So now we can find out difference here. Okay, by subtracting these two, this expression and this expression. So we may write 2 pi hc delta lambda over lambda n square, that is equals to h into r, and from here we'll get 1 upon n plus 1 whole square minus 1 upon n minus 1 upon n plus 1 whole square. Right. In denominator 1 by 4 and 1 by 4 would get cancelled out. Right. So if we'll open these brackets, what will get? H R, this is 2n plus 1 divided by n square into n plus 1 ka n plus 1 whole square. Right. Now see, if we assume that n is very much greater than 1, it is given the 50th line of Balmer series. So n is pretty much greater than 1, then we can make approximation that neglect this term and neglect this one with respect to n plus 1. Right. So from here we'll get 2 pi hc delta n over lambda n square is equals to 2HR over N cube, right? So from here we can calculate delta lambda over lambda by making slight modification, that delta lambda over lambda n is equals to, just take one lambda here and shift another one on this side, and in fact we can cancel this h bar term and two terms which is available there. So this is r into lambda n over pi n cube into c, right? This is pi n cube over c, correct. So from here we'll get lambda n over delta lambda is equals to pi n cube over c into Weber constant into lambda n, right? So this is the resolution limit we got in terms of delta lambda over lambda. Now if we'll fuse this with the concept of diffraction grating, for resolution this lambda over delta lambda must be equals to L over lambda sine theta. Then we can equate these two terms, right? So we can write L over lambda sine theta is equals to pi n cube c over r into lambda, right? So from here we'll get sine theta is equals to pi n cube c over lambda and lambda would get cancelled out, r into L, right? Here pi, this n is 50 because we are talking about 50th line of Balmer series. So n is equals to 50, c is the speed of light, r is Weber constant, and L is this width of diffraction grating. So all these parameters are known. If we substitute their respective value and calculate, then we will get theta is equals to 59.3 degrees. Okay. Also, although we can settle up to this point, no need to get the numerical value, but if we want to calculate, then by substituting these, we get theta equals to 59.3 degrees.